All right, so today I'll be demoing two features that are going to be a part of the Deephaven 0.36 release. These have been merged into the main branch of Deephaven. So if you are interested in trying either of the features that I'm about to demo, you can do so with either the Edge Docker images, so long as those are up to date as of a week or two ago, or if you build Deephaven from source, so long as you've pulled the latest from main within the last couple of weeks. So without further ado, let's get right into it. The two features that I'm going to be demoing today are native table iteration in Python and multi-table listeners in Python as well. So the first one is native data iteration. Now, up until this point in Deephaven, if you want to iterate over table data, you are required to use one of our available Python integrations, those being NumPy, Pandas, and PyArrow. Essentially, you convert a table to either a NumPy array, a Pandas data frame, or a PyArrow table, and then you can iterate over it from there. However, that's no longer the case. There will be in 0.36 native table methods that allow you to iterate over table data using either a tuple or a dictionary, and there will be row-based iterators as well as chunk-based iterators where you iterate over a chunk of rows at a time as opposed to just one row at a time. And the advantage to these is that they are much more efficient than using one of the available Python integrations. So for instance, if you want to go use a Pandas data frame and iterate over that, that requires you to copy the entire table's contents into memory all at once before you iterate, which can be a real problem if your data is large. Whereas with this, because it's doing it all chunked, you only actually copy a chunk of data at a time, thus greatly reducing the memory requirements in order to do so. So for this demo, I'm going to iterate over a simple table. It's got 100 rows in it, and it's got 3 columns. And I'm only going to be showing a simple example of each of the available new iterators. So the first one is called interdict. It is a row-based iterator that so all of these use a generator, and so generators actually yield results as opposed to returning results. They are more efficient because they reduce memory copies. And so in this case, this iterator yields a dictionary upon every loop. And so if I run this, we can see that there are 100 different print statements here, and that's because it's one for every row in this table. And I'm accessing the values in the dictionaries using the column names as keys here. The next one is the tuple iterator. This is the row-based iterator, just like the last one. We can see here that I access values as fields of a tuple rather than using this square bracket string syntax here. And when I run this example, you'll see the output looks the exact same as the previous example with 100 rows being printed. The last two I'll demo are the chunk-based iterators. Chunk-based iterators actually yield, in this case, when you do it with a dictionary, it yields a dictionary where the column names are keys and the values are NumPy arrays of rows. So in this case, with a table that has 100 rows, I am using a chunk size of 25, and that means the iterator will it'll iterate 4 times over the table. And so when I scroll down here, we can see there are 4 different sets of print statements, 1 for X, Y, and Z. The last one is the same as the previous, except it does the iteration with a tuple instead of a dictionary. So once again, I'm accessing my data using this field accessor here as opposed to dictionary access like this. And when I run this, I'm also using a chunk size of 25. So it will be 4 different loops over the course of or 4 different iterations over the course of this 100 row table. And that's native table iteration in Python. There's a little bit more to it than that, but for the sake of this demo, that's the general gist of it. Like I said, it's more efficient than anything we've had previously, and it will be a part of the upcoming 0.36 release. The next one I want to talk about is multi-table listeners. And to preface this one, I just want to go over listeners really quick. So a table listener is, as its name suggests, a way to listen to a table. Table listeners are commonly used in applications where you want to manually trigger alerts or programmatically trigger alerts from a table when some particular event happens. Say you are running some code that is looking for outliers, and then when an outlier actually shows up, you may have a table listener hooked up to it that listens to incoming data to a table, and then you can use conditional filtering to maybe alert Slack or send an email or notify somebody that an outlier has occurred. And the general use of a listener is to define a listener function. And the listener function here, it always just takes two input parameters. The first is called this update object, and the second is this is replay. Update contains all of the added, modified, and removed rows from an input table, or a source table rather. And is replay is just a Boolean flag that indicates whether or not you want to include data that existed before the current update cycle. So in this case, this listener, I'll be listening to a simple timetable that ticks once per second. And in order to actually call this listener function, I pass it in along with the source table to this listen function, which I imported from the Deephaven Python library. So when I run this code, we'll start to see the source table T tick. And if I keep up with the output here, we'll see that every time the source table ticks, I get a print statement, which corresponds here with this print statement and listener function. And then when I decide I'm done with my listener for whatever reason, I can just call stop on the listener handle, and I'll move on to my next example. So the next example is actually the new feature itself, which is the multi-table listener. And in this case, I'm actually going to listen to 3 tables at the same time. Just like before, I'm going to define a listener function. This time, it's going to take an object which I'm going to call updates as opposed to update. Updates is actually a dictionary where the input tables are the keys. So you can see I access table data from T1 here using that. T1 specifically as the key value. Same thing for T2 and T3. And then just like before, I will call, instead of calling, when listening to a single table, you call listen. And when you listen to multiple tables, you will call merged listen. And instead of passing in one table, I'll pass in a list of tables here along with my listener function. The only other thing worth mentioning here is that I'm using the walrus operator each of these 3 times just to make sure that these tables received updates during a particular update cycle. A table listener listens to a table regardless of whether or not data was added once per update cycle. So in the case that you don't get data, a table listener object, it just contains none. And so if I try to print something that's none, it'll fail. So I'm just doing a check here to make sure there's actually data that was added before I print it. And when I run all this code, we'll start to see all 3 of these tables tick, and we'll see a printout every single time they do. And then once again, like before, when I'm done listening to it, all I have to do is call stop, and it stops listening. And that's my demo for today. As I said previously, these are available in our Edge Docker images, and if you build Deephaven from source code, so long as you have pulled the latest changes within the last couple of weeks. Just be aware that documentation won't be available for these until O.36 is out.